Hi guys, you're welcome to my channel. Today we are going to be looking at a topic in mathematics and the topic is referred to as bearing and distance. Before we commence the course, I would like each and every one of us watching this video to create, if it is 1 minute, and appreciate Emmanuel, because this video is sponsored by him. So I must say a very big thank you to him, because it's one of the fellow that allow us to keep moving on this channel. You can also do the same thing like he does. So he has sponsored 2 videos, and the second one is going to be coming after this, and that is on longitude and latitude. I pray that God will bless his knowledge and enrich him with wealth as you benefit from this class. So we are wasting much of our time, so let's get started. Now, when we talk about bearing and distance, there's no way we can discuss this topic if we don't talk about the foundation of it, because the essence of a sponsored video like this is for us to break it down to the very barest minimum, so that nothing about the topic is going to be hidden to you anymore. For that reason, I'm starting with the concept of trigonometry. Trigonometry. Now, when you talk about trigonometry, what's trigonometry? Trigonometry is the study of angles in different perspectives. And you can also say it has to do with triangle. There's no doubt, you're right. And when it comes to triangle, we have 4 ways in which we find solution to triangle. One of it is Pythagoras theorem, and the second is trigonometry ratio. Trigonometry ratio. And on the other hand, we have the sine rule and the cosine rule. Now, why do I go in these 2 directions? So I made mention of these 2 types, Pythagoras theorem, trigonometry ratio, sine rule, and cosine rule. This particular method of solving triangle, it has to do essentially one with a rectangle triangle, and the second with acute angles triangle or obtuse angle triangle. So if you look at these 4 methods of solving triangle, you see that they basically depends on angle. So if I have a right angle triangle, I'll be thinking of Pythagoras theorem and trigonometry ratio. And then the application of this method is what we call elevation and depression. And when it comes to sine rule and cosine rule, the application of this is bearing and distance. Are you getting this now? Bearing and distance. So for us to do bearing and distance, it means that we already acknowledge the fact that we understand sine rule and cosine rule. So, should in case you have not, let's start with the derivation of sine rule. So when we talk about deriving sine rule, we have different methods of getting that done, of which I'm going to be exploring some of the method with each and every one of us today. So let's start with the sine rule. Okay, so the sine rule. Now, since sine rule can be applied to both obtuse and acute angle triangle, then you can as well prove it with either obtuse or acute. Is that taken now? So let's start with acute angle triangles. Let's say I have a circle. So if I have a circle, inside this circle, I have what? A triangular shape like this. Okay? And I have this. So if this is an acute angle inside a circle, let me call this one A and call this one B and call this point here C. Remember again, capital letter is to represent angle in mathematics, while small letter is to represent side. So if there is capital A, that means this is angle A and this place is going to be side A. If there is capital C, here is going to be what? Side C, and this place is angle C. So here is B, and this place is going to be what? Side B, and this is angle B. So for me to be able to prove by sine rule, there's need for me to make some other reconstruction in this circle, so that I'll be able to apply some circle theorem in order to establish my facts. So construct a diameter from B to point P. So this is a diameter because this is the center of the circle. So don't worry, don't mind my circle that the diagram is not perfect. So if here is P, let me connect this point like this. So if I connect this point like this place is going to be half a circle, and if this place is half a circle, then this angle here is going to be 90 degrees. Why 90 degrees? Angle in a semicircle is 90 degrees. That is a circle theorem. Am I making sense now? So for that reason, from this construction right here, I have that PB is a diameter. So if PB is a diameter, then it's going to be 2 radius, because diameter is radius plus radius. Am I making sense? So if that should be the case, we have that PB, that is PAB, is equal to 90 degrees, like I said earlier. That is the angle in a semicircle. Angle in a semicircle. Also, BCA is this BCA. Can you say BCA is equal to BPA? Are you seeing it now? BCA is equal to BPA. So why are they equal? Because they are on the same segment. So angle in the same segment, angles in the same segment, they are equal. Are you getting this now? So we have established this. Now we can solve. So if I say consider triangle BPA, consider right angle triangle BPA, that is this triangle here, BPA. So if you consider that is in triangle BPA, if you consider that, you have that the sine of BPA is equal to opposite, so opposite over what? Hypotenuse, and that will be AB divided by PB. Are you getting this now? So AB is what? AB is C, and PB is what? PB is 2 radius. Therefore, I will have that the sine of, now we have that sine BPA is equivalent to what? BCA. And when you look at angle BCA, you get to see that it is what? It is C. So I can say sine of C is equal to small c all over 2r. So if I cross multiply here, I will add that 2r is equal to c all over sine c, and I can call this one equation star. So if you look at this now, if I have this, similarly, just like 2r equals c over sine c, similarly, I can have this. Similarly, I have that a all over sine a is equal to 2r, also b all over sine b equal to 2r. If that should be the case, then it means that a all over sine a is equal to b all over sine b equal to c all over sine c equal to r. So this is sine rule. Now, what about if we want to use an obtuse triangle? For us to use an obtuse triangle, we're still going to get the same result. So let's look into that together. If I have what? An obtuse triangle, so let me construct a circle and then construct a quadrilateral inside the circle like this. So this is a triangle now. I'll call this B, I'll call this C, and I'll call this one A. So if I draw a diameter from B to P, so this is a diameter, even if my diagram is not up to scale, please note that this place is diameter. So I'm going to call this one point P, and this place is going to be 2r since it is diameter. Alright? Okay, so this is angle C, then where is going to be side C, and this is angle A, this place is going to be side A, and this is angle B, so where is going to be side B. Am I making sense now? Okay, so if you look at the shape BCAP, BCAP is a cyclic quadrilateral, a cyclic quadrilateral. So if I have BCAP to be a cyclic quadrilateral, that means that BCA, that is angle C, plus BPA is equal to 180 degree. Why? Opposite angle in a cyclic quadrilateral. Do you understand that now? So that's the principle. The opposite sides of what? A cyclic quadrilateral, their sum will give you 180. So angle C is opposite to angle P. So when you add them together, your result is going to be 180. So if that should be the case now, I have that angle P is equal to 180. Since BCA is angle C, this will be minus C. I don't know if you are getting what I'm doing now. Alright, so that should be the case now. I therefore have that BAP. Since this is a what? Since this is a diameter, and the BAP is going to equal to 90 degree because that is angle in a semicircle. Angle in a semicircle. Alright, so that should be the case. We now consider triangle BPA. So BPA. So considering angle BPA, triangle BPA, I will add that the sine of P, that is sine of 180 minus C, is equal to opposite. Our opposite there is going to be AB, which is this, over hypotenuse, which is 2r. So if this is what we have, then we have that sine of 180 minus C is equal to C all over 2r. When you cross multiply, we have 2r to equal to C, this is small c, not capital C, divided by sine of 180 minus C. So you are going to agree with me that 180 minus c is in second quadrant, and sine is positive in second quadrant. Therefore, sine of 180 minus c is equal to sine of c. Am I making sense? So we have small c all over sine c equal to r. Similarly, we are going to have that a sine of a equal to r, and b sine of b would also equal what? To r. If that should be the case, we can then resolve back to what we did earlier when we are using acutes. So this is going to be a all over sine of a to equal to b all over sine of b to equal to c all over sine of c equal to r. So this is sine rule, and you can as well state it this manner, that is sine of a all over a equal sine of b all over b equal sine of c all over c. Everything equal 1 over 2 radius. Okay, so if that should be the case now, that is that about what? About the sine rule. So you need to memorize that and then remember for good. Okay, so let's move to the next one, and that is cosine rule. So to prove the cosine rule, I will only be using one triangle to prove the cosine rule just because of time. So if I have this, so I label here A, and this is B, and this is C. Then this angle here is angle 90, and the height of this is h. So here will be small c, and here will be small e, and the entire line here from here to this place is going to be b. So if from here to this place is given as x, then from here to this place is going to be b minus x. Are you getting this now? So if that should be the case, then we can prove for cosine rule now, and we just consider, let me call, this line from B to this point, let me call it M. Okay, I think I need more space here. All right. Okay, so let me call this one M. So from A to M is B minus x, and from here to here is x. So the entire length here is going to be b. Are we together now? All right, so if that should be the case now, consider triangle ABM. So this is ABM. So if that is the triangle that we consider, apply Pythagoras theorems to it. We are going to have that c square is equal to b minus x all square plus h square. If you expand this bracket, you have c square to equal to b square minus 2bx plus x square, plus x square plus h square. Am I making sense? So we have what? We have this. Let me just call this one equation star. So we can come back to that later. Now consider triangle BCM. So this is BCM. So I will have that Pythagoras theorem there is going to be x squared plus h squared equal a squared. So that is equation 2. Now if you look at this now, this equation 2, before I move on, I can as well look for the cosine of c. So if I'm looking for cosine of c in this same triangle, it will be what? Adjacent over hypotenuse, right? So cosine, let me just say also, the cosine of c is equal to x all over e. So if I cross multiply here, I will have that x is equal to a cos of c. Can you get that right now? So let me call this one star, star, star. So use equation star, star to rewrite equation star. So use star, star to rewrite star. That means we are going to have c square equal b square minus 2bx plus, so instead of x square plus h square now, we are going to be having what? A square. So I'll just put a square here, right? Okay, so if that should be the case, I think I can call this equation star, 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 and star. So right now, I can rearrange this or rewrite it better as c square equal a square plus b square minus 2bx. So use equation 3, that is star, 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 to rewrite equation 4. So if you use equation 3 to rewrite equation 4, you have c square equal a square plus b square minus 2b. Instead of x, you put what? A cos c. Then you have c square equal a square plus b square minus 2ab cos c. And this is cosine rule. Similarly, you have a square equal b square plus c square minus 2bc cos of a. And also, you have b square a square plus c square minus 2ac cos of b. So these are possible ways that you can express your cosine. Now, if you are looking for an angle, you can go by saying that from this equation here, I can say cos of c is equal to a square plus b square minus c square divided by 2ab. Or I can as well say that cos of b equal a square plus b square minus there's a mistake here. A square plus c square minus b square divided by what? 2ac. And cos of a is going to become what? B square plus c square minus a square divided by 2bc. So these are useful equations under what we refer to as sine and cosine rule. So I believe we understand how to prove it now. Alright, so knowing how to prove it now, it's not enough like knowing how to apply it. Am I making sense? So let's consider that now. So we have to consider the application of sine and cosine rule. And how do we go about that? So we say application of sine and cosine rule. So what does this mean? What this simply means is that when we talk about the application of sine and cosine rule, how do we utilize the two rules? That's the essence of what we want to do now. So the first thing is for us to understand the classification of triangle. When it comes to classification of triangle, we can classify triangle in two ways. The first one is what we call lateral classification. So for lateral classification, we have what? Equilateral triangle. We have isosceles triangle. We have scaling triangle. These are three triangles that we have if we are classifying bilateral. Now, what does equilateral triangle means? Equilateral triangle means a triangle that all its sides are equal, including its angle. That is, the three angles are equal to each other. Likewise, the three sides are also equal to each other. While isosceles triangle is a triangle that at least, mark that word, put it in quote, at least two of its angles are equal and also two of its sides are equal. It's not what they define like, when they say the base angles are equal, it's not necessarily to be the base angle. Am I making sense now? It's supposed to be at least two of its angles are equal. So if two of its angles are equal, two of its sides would also be equal, at least. That means you can have the three sides equal, it's still isosceles. For that reason, equilateral triangle is an example of isosceles triangle. Do you understand that now? Okay, the scaling triangle, a triangle that none of its sides nor its angle are equal. Are you getting this now? Everything is quite different. Okay, so that should be the case. We can look at the second type of classification. The second type of classification is the angular classification. Angular classification. So when we say angular classification, we can classify an angle, a triangle, as acute angled triangle, or we classify it as obtuse angle. Sorry, this is supposed to be acute angles, not angled. Acute angled triangle, and this one will be acute angled triangle. And the third one is right angled triangle. So this is angular classification of triangle. So what is acute angle triangle? Acute angles triangle means a triangle that all its three angles are acute. All its three angles are acute. And when I say obtuse angle triangle, it means one of its angle is obtuse. One of its angle is obtuse. A right angled triangle means one of its angle is right angle, that is 90 degrees. Now, for the sake of this class, we are trying to look at the application of sine and cosine. Then the angular classification is more important to us compared to the lateral classification. The lateral classification will matter to us when we are looking at triangular theorem. Looking at triangular theorem, then the lateral classification is awesome. And when we are trying to prove the cube ratios, then the lateral classification can help. But for now, angular classification is what we are particular about. So, how do we go about that? Let's say some questions under sine and cosine rule. There are conditions in which you can use sine and cosine rule, or condition that warrants the sine and cosine rule. So if you are given a triangle, to use sine or cosine rule, it can come in four different conditions. So the triangle can come such that you are going to be given two sides. You are going to be given two sides and non-included angle. Non-included angle. Am I making sense now? So non-included angle may be given. So what do I mean here? If you have a triangle like this, you may be given side A, side B, and you are not going to be given side C, but the angle of C will be given. Do you understand this now? So you are not given this side, but you are given the angle that faces it. So you are given these two sides, but you are not given the angle that faces. That's the first condition. And the second condition is that two angles and one side may be given. Two angles and one side may be given. Two angles and one side may be given. So what do I mean by this? That two angles and one side may be given is that you can have a triangle like this, and you are going to add this angle A, you are going to add this angle B, and you only be given side of B only. or giving you side of A only. Is that okay now? So the third case is two sides and an included angle may be given. Two sides and included angle may be given. So what does this mean? That is, you are going to have what? Two sides, A and B. Then we are going to give you what? One of the angle, either angle B or angle A. Then the last one, which is the fourth one, is three sides may be given. Three sides may be given. So it can be given three sides. So when you have this, compare the parameters at hand with the two rules for you to know which is going to be better, sine or cosine. Alright. So let's consider this. The question says solve the following triangle, but I'm going to solve just one out of it because we are not really looking into sine and cosine. What we really need is bearing and distance. So solving more questions under sine and cosine rule is not going to be of help. So let's say this is a triangle now, and this side A is given as 6.8 centimeter, and this is side C given as 7.2 centimeter. So this is A, this is C, and this is B. So we are given this angle 58 degree. So the question is, we are looking for side B and we are looking for angle A and angle B. So how do we do that? We can use what? The sine rule for this. Are you getting it now? So we have A all over sine A to equal to C all over sine C. And why sine C? Because we have angle C and we have side C. So our A is what? 6.8 divided by sine of A, we don't know, equal to C. Our C is 7.2 divided by sine of 58 degree. Am I making sense now? So if I make cross multiplication, I will have that sine of A is equal to 6.8 multiplied by sine of 58 divided by 7.2, which is C. So we have that sine A is equal to press a calculator. So that will give us 0.8009. Abi? So A is equal to arc sine. Please don't call this sine inverse. It's pronounced as arc sine of 0.8009. So A is equal to 53.22 degree. So now that I have what A, I can find B. Abi? So to find B, I will have that B is equal to 180 minus A plus C, the sum of angle in a triangle. So B now is equal to 180 minus A, which is 53.22, plus C, which is 58. Then I will have that B equal 180 minus, so when you add the two together, you have 111.22. So B now is equal to 68.78 degree. So we've gotten the value for B now. So we now find the side B. Alright, so to find the side B, we can say similarly, we have B all over sine B to equal to C all over sine C. So we have what? B to be divided by the sine of 68.78 equal 7.2 divided by sine of 58 degree. Am I making sense now? So this degree. Okay, so if you cross multiply now, you have that B equal 7.2 sine 68.78 divided by sine of 58. Is that taken now? So B is equal to 7.2 sine of 68.78 will give us 0.9322. Am I making sense now? Divided by 0.8480. So B is therefore equal 7.915 in centimeter, and then I will have 7.92 centimeter. So that's the value for B. I hope this is clear. Okay, so I'll stop there because of time. So let's just move down to the main problem, that is the major business of this class, and that is bearing and distance. Bearing and distance. Okay guys, now when we say bearing and distance, what exactly are we talking about? A bearing is the direction traveled. Is what? A bearing is the direction. A bearing is the direction traveled between two points, and is always given as an angle in degree. You get that now? So a bearing is a direction traveled between 2 points and is given as an angle in degree. So a lot of people utilize what? Bearing to find their location. Are you getting it now? For example, pilots in the air, sailors at sea, and surveyors. They use what? Bearing to find their direction. Are you getting it now? So we now have what? Two methods of representing bearing. And the first one is what we call compass bearing. Compass bearing. Now, when you talk about the compass bearing, you are measuring angles. It's a compass bearing when you are measuring angles in respect to north or south. Are you getting it now? When you are measuring angle in respect to north or south, you are dealing with compass bearing. Okay, for you to understand what I'm saying here, let me give you this diagram. Sorry. If I have this diagram here, this is the four cardinal points: the north, the east, the south, and the west. If this is what I have, let's mark this place point O. Are you getting it now? So if I take my O as a starting point, and ON as the direction of the north, so the bearing of an object P from O, is the angle which OP, that is, if I take this like this and call this one P. So if they ask me that what is the bearing of this object P from O, are you getting it now? So it's going to be the angle which OP makes with ON. So the angle that's what OP makes with ON is going to be the bearing of P from O. Are you getting it now? So you have to read in the clockwise sense. Am I making sense now? Okay, so if that should be the case, if it is a compass bearing, are you going to read towards only north? We are not reading from north only. If it is a compass bearing, you have to read from south as well. Am I making sense now? Okay, so if I have, let me have another shape here. Okay, so permit me to clean this. Sorry. Okay, so okay, okay, so let us have let us have this diagram here. Are you seeing this now? So this is north, this is south, this is east, and this is west. If I have this now, if I have this angle in this direction, so if this is A and I call this place O, so from here to this place, if it is 50 degree, or I have this, and the angle here is 60 degree. Remember, this is north, this is south, this is west, sorry, this is east, and this is west. Now, if this is what I have, if you look at this angle that I have here, it is NOA. If you look at this angle that I have here, it is what? S. So let me call this one, okay, let me call this one Q and call this point P. So if you look at SPQ, that's this, isn't it? So we have this first one to be a bearing of north 50 degree what? East. Are you getting this now? It means that you are measuring angle 50 degree from the north in a clockwise direction. That's what this one means. While this one means south 60 degree west. So it means you are measuring 60 degree from south in a clockwise what? Direction. Are you following now? So you can see this one you are measuring from south, sorry, from north, and this one you are measuring from where? From south. It is going to be a compass bearing when you are having two reference points. When your reference points are north or south, you are dealing with compass bearing. Am I making sense now? So the other type of bearing is the 3-digit bearing. So when you talk about the 3-digit bearing, 3-digit bearing is usually measured from north in a clockwise direction. Are you getting this now? It's usually measured from north in a clockwise direction. So that 3-digit bearing has nothing to do with south. It's always from the north. Am I making sense now? So let me give you this. If I have let's say for instance I have this. Sorry. If I have this for 3-digit bearing, instead of having north here, you have 0 degree here. Here is 090. Here 180. Here 270 degree. So that means to move from here to this place is 90 degree. To move from here to this place 180. So from here to this place 180, and from here to this place 270, back to this place, which is going to be what? 300. And so since it is starting point, just mark it to be 0. Am I making sense now? Okay. So if somebody now say, okay, so that you are going to understand what I want to do very well. Let me give you this instance here. This is a bearing now, and this is a compass bearing. We said when it is 3 digits, when it is 3-digit bearing, you only have reference to the north. You have nothing to do with the south. Anything you want to read, you are reading from north in a clockwise direction. Are you getting this now? All right. So if that should be the case, if I say, okay, let me have a new page. If I give you the following compass bearing, write each of the following in three digits bearing. Write each of the following in 3 digits bearing notation. So I have A to equal south 40 degree east, B south 50 degree west, C north 40 degree west, D north 60 degree west, and E north 42 degree east. So I'm going to do some of this and I will leave you to do the rest. Am I making sense now? Okay. So if you want to plot a graph, that is, you want to interpret a bearing. For you to be able to interpret a bearing, you must understand it. Now, let's say we want to change this first one to 3 digits bearing. That means I will have this. So this is going to be 0, 0. This is going to be what? 90 degree, 0, 90, 180, 270. Are you following now? So since 3 digits bearing is always clockwise from the north, this is the north pole, right? So we have south 40 degree east. South 40 degree east means here in a compass bearing. In a compass bearing, it means you read what? 40 degree in anti-clockwise direction. Are you following now? That's what south 40 degree east. That's what it means. You are reading what? You are reading 40 degree from south in a clockwise, in anti-clockwise direction. Are you following? So what will not be the value if you are reading it in 3 digits? So 3 digits read from north in a clockwise direction. So the angle from here to this place. So here is 40, right? And remember, from here to this place is 90. So if this place is 40, then here is what? 50 degree. So you are going to have that south 40 degree east is equivalent to this way. We got 90 plus 50. That's 140 degree. So do you understand that now? That means south 40 degree east is equivalent to 140 degree in compass in 3 digits bearing. So the second one says south 50 degree west. When I say south 50 degree west, what it means is that south 50 degree west, what it means is that from south you read clockwisely. From south you read what? 50 degree clockwisely. Are you seeing this now? So what will be the value if you are dealing with 3 digits bearing? So you start from the north here. This is 0, 0. Don't forget in degree. This is 0, 9, 0 in degree. This is 270 in degree, and this is this is going to be 180 in degree. So you start from what? Reading from the north, then you take it this down to this place. So that will be 180 plus 50. So it means that the south 50 degree west is equivalent to 180 plus 50. That will give us 230. So that is, this is equivalent to 230 in degree. Alright, so let me answer one more, then we pause the video and answer the remaining ones. So the third one, we have this 0, 0 degree, 0, 9, 0 degree, 180 degree, and 270 degree. So what the value for that one? They say north 40 degree west. North 40 degree west. It means you are reading north 40 degree west means you are reading 40-degree anti-clockwise from the north. That's what it means. So this is 40-degree. So if there is 40-degree, here is going to be what? 50-degree. So in 3 minutes bearing, you always start from where? From the north. So you look down like this to this point here. So this one is going to be us what? This 180, 270, 270 plus 50. So that is 320, right? So that means the direction north 40-degree west is equivalent to what? 320-degree. Are you following now? So you can pause the video now and try the last two and see what your result is going to be. And when you are done, you can pause the video and see what our results will be. Okay? So for the next one, we have what? North 60-degree west. Don't forget this because we are doing with 3 digits bearing. Okay, so north 60-degree west, it means reading 60-degree from the north pole in anti-clockwise direction. So this is 60-degree. So it means here is going to be what? 30. So if I read 3 digits bearing from north, right, in the clockwise direction, so this is going to be what? 300, right? Because this is 270. 270 plus 30, that's 300. So we have that north 60-degree west is equivalent to what? 300-degree for 3 digits bearing. I hope this is clear now. Now, I know some of us might be like, oh, why are we doing this? Why are we doing? We are looking for a better way, the most accurate way of identifying direction. Are you getting this now? So if we are using compass bearing, it is very easy for you to guess what direction is going to be, but it might not be accurate. Are you getting it now? But you can easily predict where you can find it. Oh, northeast, then it means it's going to be somewhere here. Northeast is going to be somewhere here, but exactly that is going to be is what you don't know. Are you getting it now? So 3 digits bearing will give you what? Exact precision, but you might not be able to guess what the location will be. Am I making sense now? So I want you to understand this, and then we move on to the next one. So right now that you've known how to read angles in 3 digits and also in compass bearing, so anyone they give to you, you know how to go about it. Because in this modern day, what we use is the 3-digit bearing. Am I making sense now? So we now have what we call back bearing. So we have what we call back bearing. What is back bearing? If the bearing, for example, if the bearing of A from if they say A from B, what it means is that B is the starting point. Are you getting it now? B is what? The starting point. That's what it means. A from B. B is the starting point. Note that because that gives a lot of confusion to students as well. So if the bearing of A from B is given, that is, you are given the bearing of what? A from B, then the bearing of B from A is a back bearing. Is a back bearing. Am I making sense now? So if the bearing of A from B is given to you, then the bearing of B from A, this is supposed to be capital A, sorry. The bearing of B from A is a back bearing. Now, for back bearing, there is 2 conditions for it. The first condition is that when the given angle is less than 180 degree. Are you getting this now? If the given angle is less than 180 degree, then the back bearing is going to be the angle, that is the given angle, plus 180 degree. That is if this value is less than. Are you getting it now? Then the second case is when the given angle is greater than 180 degree, then the back bearing is going to be the angle minus 180 degree. Do you understand that now? So let's look at an example of the two. Okay, let's take for instance that you are given the bearing. Let me say if the bearing of O from if the bearing of A from O is, if the bearing of A from O is 50 degree. Idea now. So what does that mean? If the bearing of A from O is 50 degree, that is this. You know, if you read in this manner, this is 00, 090, 180, and 270. So that is, if you read clockwise from the north, this is going to be O, because the and I want you to start noticing this now. If the bearing of A from O is 50 degree, that means O is the starting point. So 50 degree, yeah, are you there? So you can see this is going to be point A. So here is going to be what? 50 degree. So what I now say, the back bearing. Back bearing will be that from what? The back bearing is going to be the bearing of O from A. I see it now. So A will now be our starting point now. So if A is our starting point, I'll read from here down to this place. And if you look at it very well, this angle here is 50, right? So here is alternate to this place. So here would also be what? 50. So if you look at it now, you see that the bearing of O from A is going to be 90 plus 90, that's 180, then plus what? 50. That's why we said if the angle is less than 180, then the back bearing, which is the bearing of O from A, is going to be the angle 50 plus 180, and this will just give us 230. Do you understand that now? So that's what we call back bearing. You see here, back bearing. All right. So what if we say the angle is 241? Are you getting it now? So let me take this upward. Let's say I have the bearing of A from O to be 241. So we have bearing of A from O to be 241. So this will just become this. So that will be from here now we read 241. So like this. Can you see this now? So it's going to be somewhere here, because to this place is going to be 270. Abi? So here is 00, here is 090, and here is 180. So that means from here to this point, okay, so this is point A and this is point O. So this angle here is going to be what's it called? 241. So 180 minus 241, that will give you this angle here. Am I making sense now? So 180, so 241 minus 180, that will give us what? 241 minus 180, that will give us 61 degree. Are you getting that now? So 61 degree is going to be the bearing. Sorry, this is point A now. So let me just chop this off a bit. So you're having this now. So 61, right? So that means this angle here, this is 61. It has to be alternate to this one here, 61. So if I read from north, are you seeing it now? You see, it's going to stop at 61. So that's why we say when the angle is greater than 80 degrees, just subtract 180 from that particular angle, and you have what? The bearing of A, the bearing of O from A, and this one is what? The bearing of A, the bearing of A from what? From O. I want to believe you understand this now. Okay, so since you've understand what we call back bearing, I think we are now qualified to start looking at questions. Okay, so let's look at the first question. So what does the first question state? The first question says that that is the first example that we're going to be considering. We have it to be an insect, and I think it's going to be a question. An insect moves from a point A. An insect moves from a point A to a point B. A distance of 30. A distance of 30 meters in the direction 040 degree. The direction 040 degree. Full stop. It then changes direction. It then changes direction and moves to point C, to a point C rather, and move to a point C in the direction 150 degree. If the point C is due east of A, find Roman figure 1 the distance. Find the distance of the points. Find the distance of the point C from the point B. From the point B. Roman figure 2, the B part. You find the distance of point C. You find the distance of point C from the point A. Do you get that now? Okay. This should be the case now, so we can have this. Okay, so I have the question and I believe you've also taken it down. There are some protocols that you need to understand when you are trying to sketch your diagram in bearing. Don't start from the edge of your book. It's always advisable you start at almost at the center. Are you getting it now? So, because you don't know to what direction is the bearing going to take you. so that you're not going to start what? Micromanaging space. And then at the end of the day, you get the wrong diagram. Is that taken now? So please caution, take caution of that. The question says that an insect moves from a point A to a point B. So this is point A. Let me move my hand closer to somewhere here so that we have enough space here in case. So this is point A. So the question says what? An object, an insect rather, moves from a point A to a point B, a distance of 30 meters in the direction 40 degrees. So direction 40 degrees. So we are starting from here, reading from the north. So 40 degrees will be somewhere here. Are you seeing it now? So if that should be the case, so we have this. So here is going to be 40 degrees. Am I making sense now? So this is point B. Are you seeing it now? So this place is going to be what? Point B, because the question is what? An insect moves from a point A to a point B. Do you get that now? A distance of 30 meters. So from here to this place is 30 meters. Are you getting this now? The question now says, it then changes direction and moves to a point C in the direction 150 degrees. Now, if the direction, when it gets to this place, that's when it now changes course to point C. In what? In the direction 150 degrees. So start from the north here and read 150 degrees. So that will be somewhere here. Abi, since from here to this place is 180, you therefore have what? This to be this. Okay? Let me get this better. Okay, so this place from here to this place now is 150 degrees. So if from here to this place is 150 degrees, then here is going to be what? That will be 180 minus 50. So here is going to be 30 degrees. And this is 40 degrees. Here is going to be what? 40 as well. Alternate angle. Am I making sense now? Okay, so this is going to be point C. Am I making sense now? So if here is 30, that means here is also what? 30 degrees. That means this angle here is going to be what? 60. Since from here to this place is 90. I believe you understand what I'm doing right now. So the question now says what? If the point C is due east of A, so that means point C is directly opposite to A. Can you see that now? So what exactly do I also look from? So the question now says the distance of point C from the point B. Okay, so how do we go about that? Remember, this total angle here is 70 degrees. So if this angle is 70 degrees, here is 60 degrees, what will be the value of this place? So the value of this one is going to be 50 degrees. Do you understand that now? Because here is 40, so from here to this place is going to be 90 minus that, you have this. Or you say 70 plus 60 minus 180 minus 70 plus 60, you have what? Your 50. Do you understand that now? Okay, so if that should be the case now, this is point A, point B, and point C. So here is going to be small letter B, here is going to be small letter A, and here is going to be small letter C. So we have triangle ABC. In triangle ABC, I have that A is 50 degrees, that is angle A is 50 degrees, and then angle B is 70 degrees, and then angle C is 60 degrees. Are you following? So side C is 30 meters, then BC is A and AC is B. So we are looking for that. So since I have them one side I have almost the three angles, I can use sine rule. So you say using sine rule. So you have to state what you are using at every point in time, especially if you are a wire candidate. So using sine rule, and we have that A all over sine A is equal to C all over sine C. Are you following? So from here, our A is what? Is unknown. That's what we are looking for, because that's the distance of the point C from the point B. So we have what? A all over sine of 50 to equal to C, that will give us 30, right? All over sine of 60. So we cross multiply, we have that A is equal to 30 multiplied by sine 50 divided by sine of 60. So this will give us what? That will give us 30 multiplied by 0.7660 divided by 0.8660. Do you get this now? Okay, so if you take this fraction, you have that A is equal to 26.54. So are we given any restriction? No restriction. So we can stop here and call this meter. And if you want to put it in one decimal place, that is 3 significant figure, you have what? 26.5 meter to 3 significant figure. Is that taken now? Okay. So the same way is what we are going to do to find the next one. So we say similarly, B all over sine B is equal to C all over sine of C. So what's our B? The value for B we don't know, but sine B, that's 70, sine 70 degree equal C, our C remains 30 divided by what? Sine 60. So if you cross multiply, you have B equal 30 multiplied by sine 70 divided by sine 60. So B is equal to 30 times, so sine 70 is 0.9397 divided by, so sine 60 0.866, right? So if you take this, we have that B is equal to 33. Please press a calculator for me. It should be 32.55 in meter, or the one that's to 3 significant figure, you have 32.6 meter to 3 significant figure. Okay, so have you seen the way we are able to answer that now? Okay, so let's take a look at another one. So another question states that city Y is 200 kilometer and in the direction 48 degree from city X. First off, city Z city Z is 80 kilometer and in the direction 108 degree from city Y. First stop. Find a distance. Find the distance of city Z from city X. be the bearing of city X, the bearing of city X from city Z, given your answer, given your answers correct to three significant figures. Giving your answer correct to three significant figures. Okay, so this is a question that we have at hand. It's also a WAEC question. So I decided to pick all these exam questions so that it's going to be well standard for you to practice with. Okay, so the first thing to do here is to try as much as we can to sketch the diagram correctly. Abi? Okay, so let's see how it goes. City Y is 200 kilometer and in the direction 48 degrees from city X. So since it says from city X, that means X is your starting point, because that's what majority don't know how to interpret. You always need to know your starting point. Do you understand that now? Okay. So if you have the word from and from, if I say from X to Y, from X to Y is different from Y in the direction. It's different from when if I say X to Y, it's different when I say Y from X. Y from X means I'm starting from X. From X to Y means I'm starting from what? X. Are you getting that now? So please get that terminology. You need to get it right. Okay, so back to this now. So we are on bearing of 48 degrees, right? So 48 degrees will start from here to somewhere here, right? Since we are using the 3 degrees bearing. So we add this to go like this. Are you seeing this now? So this is going to be city Y. So this is city Y, and here is 48. Here is 48 degrees. So this is city X here. Am I making sense now? So the distance from city X to Y is 200 kilometers. Are you following? So this angle here is also going to be 48. Alternate angles are equal. So let's move on. Let's move on now. City Z is 80 kilometers and in the direction 108 degrees from city Y. So from here, I'm going to read 108. 108 should be somewhere here. Then I'm going to add what? My city Z here. So this from here to this place is 108 degrees. So if here is 90 minus 108. 90 minus 108 will give us what? 90 minus 108. Okay. Okay. Instead of me looking for this side, let me just look for this side once. So that will be 180 minus 108. So this will give me 72 degrees. So if here is 72 degrees, then here is going to be what? 90 minus 72. So 90 minus 72 will give us, this is 8, that should be 18. Abi? So this place is 18 degrees. So if here is 18 degrees, then we can now solve now. Okay? So what's the distance? 80 kilometers. Then I need to adjust this. Sorry, I'm distracted because I'm perceiving as if something is burning, and I'm trying to figure out where it is. Okay, so let's just go on. I pray it's not going to be a dangerous stuff. Okay, so this is Z here. So from here to this place is 80 kilometer. That's why it's shorter compared to this one. Am I making sense now? All right. So if that should be the case now, I can now find. I'm having an issue with this diagram here. So let me just connect this to this. Can you see that? Okay. So if I have this now, from here to this place, it's going to be 72 degree. That is alternate angle, right? Okay. So if here is what? 72 degree, then this place is going to be what? 18 degree. What about this small space? Okay, so we'll come back to that place later. All right, so let's just go on with what we have at hand right now. So 72 plus 48, 72 plus 48. So that's 120. So the angle here is 120. Abi? So this is going to be small y. So small z, and this is going to be small x. Are you following now? Okay, so since we get our diagram correct now, we can now solve. That is, we have our small y to equal to xz, and we have our small z to equal to xy, which is 200 kilometer, and we have our yz to be what? 80 kilometer. So xy, sorry, y, which is xz, is the distance of z from what? From x. So what are we looking for? The first one states that we should find the distance of city z from city y. So we are looking for this. Since we only have this angle and we are looking for this side and we have the other two sides, we can use what? Cosine rule. So we state it using cosine rule. You have that y square is equal to x square plus z square minus 2xz cos of y. Do you understand that now? So this in turns equal 80 square plus our z 200 square minus 2 times 80 times 200 times cos of 120 degree. So y square is equal to 6,400 plus 4,000 plus 32,000. Are you following? Cos of 60. Now I know you might be surprised, why cos 60? Because cos 120 is a second quadrant and cos in second quadrant is negative. So we have that cos of 120 is equivalent to negative cos of 60. Do you understand that now? So that's why I have plus there and replace it with what? Cos 60, because it will be very easy for me to deal with that compared to when it is in minus. So we have y square to equal to, so add up everything. When you add everything together, you are going to be having, that is this plus this will give us okay, let me get my calculator. This is going to be 40,000. Yeah, 200 square is 40,000. So if I have these two together, I will have 46,400 plus, so this is 32,000. Cos 60 is 1 over 2. 32,000 times cos 60, that will give us 16,000. So y square is equal to, have these two together, you have what? 62400. Am I making sense now? So y now is the square root of 62400. So y is equal to 249.8 kilometer. Are you seeing it now? So the question is to do what? To take significant figure, you have that y is equal to 250 in meter. 250 meter. That's 3 significant figure. Please, you have to put dot here. If you don't put this dot here, this 0 is not going to be significant. Are you getting it now? So don't forget to put the dot there. Put the dot there, and that makes the 0 to become a significant figure. So this 3 significant figure now in kilometer. All right. So we have answered question 1, that is A. So let's go to B part of the question. So the B part of the question states that we should find what the bearing of city X from city Z. So we are looking for the bearing of city X from city Z. How does that mean? Let's go back to our diagram again so that you will understand what it asks us to look for. So we are looking for the bearing of what? City X from city Z. Abi? That means you want to start reading from here, from this 72 degree here, from this north pole here. You read down to this place, and that will be 180 plus something. Are you getting it now? So from here to this place, that will be the bearing we are looking for. Is that taken? Okay. So let's see how we can go there. We are looking for, if you're able to get from here to this place, then we can get the value of this angle here. Do you understand what I'm saying there? All right. So let's go into that. Because I know that is where majority of students always have problem when you're looking for the bearing of something instead of the distance. The distance is always easy to find. Okay. So to find the x, z, y, that is where we are looking for, right? So we use sine rule. And that will make us have the sine of z divided by 200, which is the small z. That's equal to sine of 120 degree all over y, which is 249.8. Are you getting this now? Why am I using 0.8? Why can't I use the approximate value? If you use the approximate value, you will not get the actual answer. Are you getting it now? So that's why I'm using this one with the decimal. Is that taken? So if I cross multiply here, I will have that sine of z is equal to 200 times sine 120 divided by 249.8. Am I making sense now? And this should give us, so when you press your calculator, this should give us 0.6934. All right. So I'll have that the sine of z, which is equal to 0.934. So arc sine, so z is equal to arc sine of 0.6934. So we have that z is equal to 43.90. So if z is 43.90 degree, is that the bearing? No. Am I making sense now? That is not the bearing. So let's go back to the diagram so that you understand what the bearing will be. So what we just get right now is the value of this place. Am I making sense now? We just get the value of this point here to be what? 43 point what? That should be 43.9. So we just get 43.9 for this, for the value of this place. Now, what are we looking for now? We are now looking for the bearing. We are looking for the bearing. Am I making sense now? So for us to get that bearing, if I move round like this, if I move from this north back to this place, that's 360, isn't it? So for me now to get the value of this small space here, which is the bearing that we are looking for, this small area, if you read from here now, you stop here. So this is the point we are looking for. For us to get this, of course, I can just say 360, that is right from here to this place. For me to get the value of this small space, I will say 360 minus this. Are you getting it now? 360 minus the sum of these two. That will give me the answer I'm looking for. Am I making sense now? Okay. So the bearing is going to be the bearing. I hope you understand that now. So the bearing of CTX from Z is 360 degree minus 72 degree plus 43.9 degree. Are you seeing this now? So this is going to be 360 degree minus 115.9 degree, and that will give me 244. Are you getting this now? That will be 244.1 degree. So to three significant figure, I will have that the bearing of CTX from CTZ is equal to the three significant figure, that's 244 degree. Do you understand that now? Okay, so let me just show you once again how we are convinced that we are correct for that. So you get to see now that if I start reading from here like this from here to this place is going to be what? 180, Abby? Then plus whatever I have here. Are you getting this now? So that means we are having 180 plus this small angle here. So if our total movement from here to this place is what? 244 degrees. So let's see if the summation of everything will give us 300. Of course it will. So 244 plus this value is going to give us 115.9. So this one is 0.1, don't forget. So if you add everything together, you have what? 360 degree. I believe you understand that now. So this is what we just calculate for. Okay, so I believe you understand this. Clear? Thank you. Okay, so let's we're running out of time already. Okay, so because I think the lecture is close to 2 hours now, so let's take a look at one more question then. So after that one question, we can call it a day. Okay, so the question here states that P is on the bearing of 015 degree from Q, and R is on the bearing of 140 degree from P. First stop. And A states if QP is 24 meter, and RP is 30 meter, find the distance between R and Q. Find the distance between R and Q to three significant figure. And B, find the bearing of R from Q. Are you getting this now? Give your answers correct to 2 decimal places. Okay, so this is going to be our last question, and I want you to pay attention to it. So you can see that there's nothing difficult in bearing. It's just so simple. What you just need is your confidence and read carefully. Am I making sense now? Okay. Okay, so if I have this now, so what will I do? Let's interpret the question. The question says that P is on the bearing of 15 degrees from Q. So that means we are starting from Q. Are you getting this now? So we are starting from Q, and that is 15 degrees. So 15 degrees will be somewhere here, very narrow. So we have from here to somewhere here. Can you see that now? Okay, and this is going to be point P. Okay, so what's the next thing? We'll say P is on a bearing of 15 degrees from Q, and R is on the bearing of 140 degrees from P. So that means 140 degrees from P, you have to be somewhere here. Are you getting this now? Then we have this. So this is 140 degrees. So if that is 140 degrees, here is going to be 40 degrees. Are you getting this now? And this angle here is going to be 15. So since here is 15, am I making sense now? Okay. If QP is 24 meter, so here is 24 meter, and RP is 30 meter. So don't forget, this is R. 30 meters supposed to be longer. Okay, so let me just increase the size of this. Okay, so this is 30 meter. So what else? Find the distance between R and Q. So this is going to be our point R. So we are looking for the distance between them, the R and Q. So this is small p, this is going to be small r, and this is going to be what? Small q. Am I making sense now? So since we get our diagram right, we can go on to look for whatsoever they want us to look for. Okay? Alright. So we can therefore say that this angle here, that will be 15 plus 45, right? So this is angle 55 degree. And we are looking for this, so it means we are using what? Cosine, right? So using cosine rule, you therefore have what? P square to equal to r square, which is 24 square, plus 30 square minus 2 multiplied by what? 24 multiplied by 30, then cos of 55. Are you following now? So this will give us 24 square, that will be 576 plus 900 minus, if you multiply all this together, so this is in first quadrant, so there's no point, so this will be what? 825.95. So I multiplied everything together, including cos 5. So this is going to give us 650.05. all right, so this is what we have. I'm trying to manage time. Okay, so P square is therefore equal to 650.05. so P is square root of 650.05. so punch your calculator, that will give us what? This is going to be in centimeter, so that should give us 25.496 in centimeter. But the question says that you should do what? Leave your answer in 2 decimal places. So we have 2, 5, then this one is going to be 0.50 in centimeter. So do you understand that now? Okay, so for me now to get what? The second question. What's the second question, please? Okay, find the bearing of R from Q. find the bearing of R from Q. So let's look into that. Bearing of R from Q. Bearing of R from Q. Mind you, maybe I should withdraw this straight line here so that you'll be able to understand what it's going to be. Okay, because it's not directly at the east part of it. So let me clean this so that we can get something clear there. Okay. Okay, so let me just say this is R. There's an angle here right now. Am I making sense now? So if I read from north down to this angle here, that will be the bearing of R from Q. Do you understand that now? So if I read from here like this down to this point, that will be the what? The angle that I'm looking for. Do you understand that now? Okay. And you can find it in the other way. If you want to use the backward bearing, you can just find the bearing of Q from R. So if I get the bearing of Q from R, if the value is greater than what is it called? If it is greater than 180, then I can just say this value minus 180 to give me the value for Q. It will give me the value of R from Q. That's backward bearing. Do you understand that now? Okay, and I believe it's cleared. Okay, so let's move on now. So which one are we using? Anyone can be used. So let's just go with the one that is kind of easy for us to do. So I will say sine of R divided by 24 is equal to sine of 55 degree divided by 25 point. Don't pick the approximate value. You pick the what? The actual value. So sine R is therefore equal 24 sine 55 degree. So that will be easy for me than me looking for the value back Q. It's not going to be that easy. Okay, so this is going to be 0.7711. Are you following? So I'll have that the arc sine, I will have that R is equal to arc sine of 0.7711. So R equal what? 50.45 degree. Do you understand that now? So if that should be the case, this angle is what? Is less than 180 degree, isn't it? So since it is less than 180 degree, then I can say since it is less than 180 degree, I can just say that this angle here is what we just calculate for now. That is 50.45. Are you getting it now? So 50.45 plus this minus 180 will just give us this. So that's so simple. Okay. So we're going to get that angle Q is equal to 180 degree minus 50.45 plus 55, the sum of angle in a triangle, and this will result to 74.55 degree. Do you understand that now? So the bearing of R from Q. So the bearing of R from Q is now going to be what? Let's check. The bearing of R from Q is now going to be this. We have been able to get the value of this angle here. So the angle we've got now, that is the 74.55, right, is for this place. 74.55. So if I want to read from the north down to where this particular line is, it's going to be 15 plus that particular value. Do you understand that now? So that means the bearing, of R from Q is going to be 74.55 plus 15, and that will give us if I add this and this together, that should give us 89.56 degree. So that's the bearing. Is that taken now? Okay, so if it is now that the bearing of Q from R, so that will be backward bearing, right? So that will be 89.56 degree plus 180 degree, and that will give us 260.56 degree. I believe it's cleared now. All right, so that's going to be a very good place for us to stop. I hope you understand this topic very well now. So don't forget to drop your comments in the comment section. Tell me what you learned, and like the video and also share with your friends. And don't forget to pray for Emmanuel. Yeah, he did well because he paid for this particular video in order for others to benefit from it, and that's why you see it to be so details like this. So see you guys in the next video.